Mr. Kaywood filled out a bracket for the NCAA national tournament. Based on his knowledge of college basketball, he has a 0.59 probability of guessing any one game correctly. What is the probability he will pick all 32 of the first round games correctly? Well, anytime we want to find a probability, we have a lot of different ways of approaching a solution. What's nice is in the situation where we can use a distribution in order to calculate the probability, because those are very systematic methods. If you'll notice, in this particular case, Mr. Kaywood would either guess a game correctly or incorrectly. So there's only two potential outcomes, which is very suggestive of a binomial distribution. We have a fixed number of trials. So there's 32 games in the first round, so he would be picking 32 games, one outcome, and would either be wrong or right on each one. So a fixed number of trials. And we can assume these are independent because he's got a 59% probability of guessing any one game correct, and that's not going to change from one guess to the next. So we can assume independence, and therefore this meets all the requirements of a binomial distribution. So when doing a binomial distribution, the things that are important: the number of trials, the probability of success, and then x, which is the number of trials that we wish, or the number of successes that we wish to observe. So n, we have 32 games in the first round. P is 0.59. X, in this case, we want to see if he will guess all 32 correct. So we'll put 32 in. Now, in order to do a binomial probability, we have two functions in the calculator that can help. Binom PDF and binom CDF. If we are only interested in a single outcome, so oftentimes the wording says exactly X number of successes out of the sample. But if it's just a single outcome that we're interested in, then we want binom PDF to help us. We have the inputs are N, P, and X. So the number of trials is 32. Probability of success on any given trial, in this case, is 0.59. And we want to know what's the probability of getting all 32 of these correct. So using the calculator, we'll hit second and vars, which will take us to the distributions menu. If we come down, we will run into binom PDF, the function we're interested in. We'll give it those three inputs, 32, separate each input by commas, and that will give us our answer. Now, this answer might look a bit strange. Probabilities are numbers between 0 and 1, of course, but here we have 4.64. The reason that we have a number this large is because it's actually in scientific notation. So this is really 4.647, I think it was. Well, it would round to 8. I'll put an 8. And then e negative 8. This e minus 8 is the way that the computer or the calculator represents scientific notation. So it's the same thing as 4.648 times 10 to the negative 8th power, which if you change that into decimal notation, you would have 0.000000, that's 6. I need a 7th. So that would move it 8 places, and then I have my remaining significant figures. So it's just an extremely small probability, so the calculator switches the notation. Now, in terms of answering, you can actually answer in the blank with the E notation. You can answer in the blank with, usually, You can answer with the times 10 style notation, or you can answer with a decimal. However, if you round it to 3 decimal places, it's going to look like 0. So I would generally recommend in this case to round to at least a few significant figures. If you take it to at least the 4/6, that's fine, but since we already have it to this amount, yeah, that's what I would recommend if you write it in decimal notation. What's the probability he will pick exactly 20 games correctly in the first round? Well, N and P are still the same. There's still 32 games. There's still a 0.59 chance of answering correctly. The only thing that's different is the number of trials that we wish to observe is now 20. So we would use binom PDF, 32, 0.59, and 20. So putting that into the calculator, we've got 0.1331. What is the probability he will pick exactly 11 games incorrectly in the first round? So if we want to get exactly 11, we know that x should be 11. But here he wants to guess them incorrectly. So the thing that happens there is instead of using p as 0.59, we would use the opposite, which would be 1 minus 0.59 or 0.41. So we use the complement to that probability. So in this case, we would use binom PDF. There's still 32 trials, but the probability of guessing incorrectly is 0.41, and we want to see 11 incorrect guesses. So binom PDF, 32, 0.41, 11. And to 4 decimals is what I'll use, 0.1094.